Hi students, in this video we will be seeing the prism derivation. Prism derivation is divided into two parts. First we will derive all the geometrical aspects of the prism and the relationship between the deviation as well as the incident and refracted angles. After that we will be discussing the angle of minimum deviation derivation for the prism. Watch the video till the end to get the complete derivation. If you have not yet subscribed to EC Exam Academy channel, please do subscribe and click on that bell icon. Let's get started. So the angle of minimum deviation of a prism is given by mu is equal to sine of a plus delta mean by 2 divided by sine of a by 2. This is the prism diagram that you need to draw. Draw all the derivation diagrams neatly with scale and pencil and mark it as follows. When the light is entering the prism, it deviates. That means it undergoes a refraction like this. It bends towards the normal and again it undergoes a refraction and bends away from the normal. So it goes like this. So this is rarer medium to denser medium and this is denser medium to rarer medium. Because of the peculiar shape of the prism, this is able to bend the light and cause the dispersion. Consider the incident ray P. If the prism was not here, then the incident ray would have gone in the straight path. But because of the introduction of the prism, the ray P is deviating like this and coming out as S. So the angle between the deviated ray and the original ray is called to be the angle of deviation. The derivation for this is completely geometrical. Let us discuss that. Consider the triangle QMR. By using the exterior angle sum property of the triangle, I can write D1 plus D2 is equal to delta. But here you can see I1 is equal to D1 plus R1 because that is vertically opposite angles. I and D1 plus R1 are. Similarly, I2 is equal to D2 plus R2, vertically opposite angles. Substituting the value of D1 from here, D1 equal to I1 minus R1 and here D2 is equal to I2 minus R2. Substituting the value of D1 and D2 in the first equation, I can get I1 minus R1 plus I2 minus R2 is equal to delta. So delta is equal to I1 plus I2 minus R1 plus R2. This is the second equation. Now consider the quadrilateral AQRN. AQRN. Since X and Y are the normals, I can tell angle Q, angle AQN plus angle ARN equal to 90 degree plus 90 degree, 90 degree plus 90 degree, which is equal to 180 degree. Since the opposite angles are supplementary, I can conclude that AQRN is cyclic quadrilateral. Now I can write angle A plus angle N is also equal to 180 degree. Now consider the triangle QNR. Here R1 plus R2 plus angle N is equal to 180 degree because angle sum property of the triangle. Angle N can be written as 180 degree minus R1 plus R2. So from the result that was obtained in the previous page, angle A plus angle N is equal to 180 degree. Substitute the value of N here. Angle A plus 180 degree minus R1 plus R2 is equal to 180 degree. Cancelling on both sides. Angle A is equal to R1 plus R2. So finally, angle A, which is called as apex angle or the angle of the prism, is equal to the R1 plus R2. Substituting the value of this in the second equation, delta is equal to I1 plus I2 minus R1 plus R2. So we can write delta equal to I1 plus I2 minus angle A. This I2 is called as the emergent angle and I1 is simply named as incident angle, that is I. So the prism equation is delta is equal to I plus E minus A, which you need to remember. Now coming on to the minimum deviation. The minimum deviation will occur when the incident angle is equal to the emergent angle. That means the ray inside the prism is parallel to the base. The point here to note down is whenever you are drawing a generic prism, do not put the ray inside the prism to be parallel as base. Always put it a little bit slant, like as I have shown here in the QR, so that you will not get confused. It is parallel to the base only when in the case of minimum deviation. Now let us proceed to derive the minimum deviation. We know the Prism equation delta is equal to I plus E minus A. The minimum deviation occurs when I is equal to E and R1 is equal to R2. So R1 can be written as R2. I1 is equal to I2. So from here I can tell R1 plus R2 is equal to A. So I can write 2R is equal to A and R is equal to A upon 2. From the equation 1, delta is equal to I plus I minus A. Delta is equal to 2I minus A. I is equal to A plus delta by 2. Using the Snell's law, which states that sin I by sin R is equal to mu, we can conclude that mu is equal to sin of A plus delta by 2 divided by sin of A upon 2, which is the required expression. If you like this video, share it with your friends and don't forget to subscribe to our Easy Exam Academy channel and click on that bell icon. If you have any doubts related to the questions, please do leave a comment, and if you want some chapter video or some derivation video or any question video, leave it in the comment. I will put a video regarding this. If you like this video,